This is Chapter 10, Lecture number 2. Open up to page 5 in the notes. The mole represents the number 602,000 billion billion. 6.02 sectillion is the proper way of saying it. The mole is an extremely large number. If you had 6.02 times 10 to the 23 pennies, and we counted a penny a second, and we took all 6 billion people on the planet, and we worked a 48-hour work week, so everybody working overtime, counting a penny a second, it would still take us 10 million years to count out a mole. It's an unbelievably large number. If you have a mole of popcorn kernels, they would cover the entire United States and extend 9 miles high. If you have 6.02 times 10 to the 23rd cute little kittens, they will cover the entire surface of the planet and extend 20 million kittens high. Why is there such a large number? Because we're using it to count such a small thing, the atom. However, a mole can be used to represent mass. A mole of carbon atoms has a mass of 12 grams. So if we look at a periodic table and we look at the mass of carbon, that represents 1 mole. So 1 mole of carbon weighs 12.0 grams. 1 mole of carbon will have 6.02 times 10 to the 23rd carbon atoms. That's a very important relationship. This is called its gram atomic mass. So using the periodic table, if we have a mole of helium, it will weigh 4.0 grams. And it will have 6.02 times 10 to the 23rd atoms. A half a mole of O weighs 16, so half a mole of O will weigh 8 grams, and it will have half the number of atoms, 3.01 times 10 to the 23. 2 moles of xenon will have twice the periodic table, so it will weigh 262.6 grams, and it will have 12.04 times 10 to the 23rd atoms of xenon. 1 mole of magnesium will weigh 24.3 grams, and it will contain 6.02 times 10 to the 23rd atoms of magnesium. So we have a relationship between mass, which changes, and atoms, which a mole will always be 602,000 billion billion atoms. Now this next part is not hard. It's just using the mass from the periodic table to find what 1 mole weighs. 1 mole of a molecule is the mass from the periodic table. So what does 1 mole of sulfur trioxide weigh? Well, first we need the formula for sulfur trioxide, which we should know is SO3. Then we have to figure out from the periodic table what does sulfur weigh and what does 3 oxygens weigh. Sulfur weighs 32.1. 3 oxygens weigh 48.0. Make sure you check and see, and then we just add them together. So a mole of sulfur trioxide will weigh 80.1 grams. An ionic compound is the exact same thing. An ionic compound is composed of formula units. This time it's called a gram formula mass. The Roman numeral 2 means iron's charge is +2. Chlorine's -1, so the formula is FeCl2. So we need to find the mass of iron and 2 chlorines. Iron from the periodic table is 55.8. Chlorine is 35.5 times 2, which is 71.0. So 126.8 grams. Gram atomic mass represents the mass of a mole of an element. Gram molecular mass represents the mass of 1 mole of a molecular compound. Gram formula mass represents the mass of 1 mole of an ionic compound. And then we're going to make life easier. We're not going to get bogged down with which term to use. We're just going to use the term molar mass. The molar mass of the substance is the mass in grams of 1 mole of the substance. So the molar mass of helium is 4 grams per mole. So we're going to flip backwards a couple of pages and find page 3, determining the number of particles in a mole, and we're going to do the bottom 2 problems. Here's where it gets a little confusing if you don't understand the terms, but this is all about setting up a proportion. If you're good with proportions, it might take you a minute or two to get used to the chemistry terms, but it's the exact same thing. So how many molecules are in 3.50 moles of sucrose? Well, if you have a mole, you will always have 6.02 times 10 to the 23rd, whether it's molecules, ions, atoms, books, bridges, chimneys, it doesn't matter. 1 mole is 6.02 times 10 to the 23rd. In our proportion, we want to know how many are in 3.50 moles. So if you can set up that proportion and understand what it means, it's going to make this chapter that much easier. We cross multiply, which I'm usually not going to do. This step, I'm just going to show the answer. So x equals 6.02 times 10 to the 23rd times 3.50. When you put these numbers in a calculator, I strongly suggest you use parentheses so that the math operations don't get messed up. And x equals 2.11 times 10 to the 24th. Make sure you have the right unit. How many molecules? And the last problem for today, here's a formula unit. That's why you have to know what these terms mean, otherwise that's going to confuse you. If you have a mole, it doesn't matter what it is. You always have 6.02 times 10 to the 23rd. In this case, it's a formula unit. So now it wants to know, what if you have 4.92 times 10 to the 22 formula units? So this time x is in the numerator. I'm not gonna, well, I'll do this one. We cross multiply, which I'm normally not gonna show. To get x alone, we divide. calculator, we do our math, we get 0.0817. How many moles? And that's the math that we're going to be using for Chapter 10. Most of it is setting up proportions. So that's it for today, and we will see you in class.